Okay, two more useful functions here. Let's start with the length function. For a vector, the length function returns the number of elements. For a matrix, the story is different. It returns either the number of rows or number of columns, whichever has the large value. You can see this in the below example. Size is another built-in function which returns the number of rows and columns in a vector or in a matrix. Please see the following example here. Naturally, after learning the length and size functions, you may ask yourself, what is the function that computes the number of elements in a vector or in a matrix? While the length function does this job for vectors, we need another function for matrices. This function is called numel. Note that this function can be used for both vectors and matrices. See the examples below here. MATLAB offers a built-in function which returns the index of the last row or column in a matrix. The function is called end. So, for example, if I would like to know the element in the last row and the first column of a matrix, then I can do that by using end function, as depicted in the following example. We have already seen a transpose operation on matrices. It essentially changes the matrix shape. MATLAB has several such routines, which allow reshaping the matrix. The one that I will teach you here is called reshape function. Basically, you give this function a matrix and the number of rows and columns of the new matrix. The function then rearranges the matrix elements so that the new matrix has the given number of rows and columns. For example, here we have a matrix with 3 rows and 4 columns. Here, the reshape function is required to reshape this matrix into a 2 by 6 matrix. Note that the original matrix has 12 elements, so it is possible to rearrange those elements in 2 rows and 6 columns. The rearranging of the elements is done based on a column-wise fashion. That is, MATLAB starts by reading the first column and pick the first 2 elements to form the first column of the new matrix. Then it picks the last element of the first column and the first element of the second column to form the second column of the matrix. Next, it picks the second and third elements on the second column and constructs the third columns of the new matrix. This is repeated until the new matrix is built. You can see how this function is implemented in the example shown in this slide.